And, it was kind of like a light bulb moment where I had to thump myself on my head and just say, it's about carbon, stupid. It's about carbon, stupid, is really where we are at. It also is fundamentally life-giving.
Welcome to the 387th installment of Ear to the Ground, the Land Stewardship Project's podcast on family farming, regenerative agriculture, community food systems, and local democracy. I'm Brian DeVore, editor of the Land Stewardship Letter. I can count on one hand the number of times I've had a conversation that profoundly changed the way I viewed the world, or at least certain aspects of it. One of those conversations was with soil microbiologist Chris Nichols. In 2012, I traveled to North Dakota to do a story on the Burleigh County Soil Health Team, which at the time was revolutionizing not only the way we view soil health, but the way farmers, scientists, and conservation professionals can work together. After visiting Gabe Brown's farm and seeing firsthand how he was utilizing cover crops, diverse rotations, and managed rotational grazing to build soil profitably, I talked to Jay Fearer, a soil conservationist who was coordinating the team at the time. My interviews with Brown and Fearer were eye-opening, but what really put things into mind-blowing context was a visit I paid to Nichols at the USDA's Northern Great Plains Research Laboratory in Mandan, across the Missouri River from where Brown farms. At the time, Chris was seeing her views of how farmers can have a positive impact on life in the soil turned upside down. As she explained to me back then, as a student, she was taught that a farmer could not have a positive impact on soil organic matter in a typical lifetime. But while working with Brown and the other farmers in Burleigh County, she saw firsthand that in fact they could increase organic matter levels, which impacts everything from how well the soil soaks up moisture and stores it, to whether it has the ability to cook up its own natural fertility. At one point, Chris showed me some slides of microorganisms and explained to me how they could conduct what she called habitat engineering. In effect, creating a living world that is self-perpetuating fertility-wise, resistant to erosion, and, in general, resilient in the face of extreme weather, disease, and pests. I walked out of her office with a flipped view of farming's potential relationship to soil. As Jay Fear likes to say, no longer must we accept soil as a degraded resource. Regenerative methods, modeled after natural, ecologically based systems, can take us beyond just sustaining the soil and actually bring it back to life, improving it in the long term while producing multiple agronomic, economic, and environmental benefits. Chris grew up on a farm in southwestern Minnesota and has spent over 3 decades studying soil. What has always impressed me about her is she's the type of scientist who can pivot the way they view things once some compelling counter-evidence from a farmer's field emerges. So, when she recently presented at a field day in southern Minnesota, I jumped at the chance to catch up with the microbiologist and find out what's new in the world of soil health and its relationship to regenerative farming. It was a fitting place to conduct the interview. The field day Chris was presenting at was hosted by Tom and Alma Cotter, farmers in the Austin area who, in recent years, have emerged as leaders in using regenerative farming to build soil health profitably. After Tom led a tour of his diversified fields and grazing paddocks and explained how he's using a systems approach to produce crops and livestock regeneratively, Chris sat down to talk with me. What follows is the first of a 2-part podcast. In this installment, the scientist chats about how dogmatic thinking related to soil leads us down an unsustainable path, the importance of differentiating between practices and principles, and why we should all take a carbon-centric approach to viewing the land. Chris also concedes that what fuels her passion for soil health is a love affair she's had with a certain fungi since she was in college. Chris, I first met you more than a dozen years ago in Burleigh County with the Burleigh County Soil Health Team and the work you were doing with Jay Fear and Gabe Brown and those folks. And that was one of the first times I had really been introduced to this idea that maybe what we learned in college about soil was not the whole story, that there had been some real advancements in science, and you were working with that, and you were working with farmers and seeing that they were seeing that on the ground. And then you were kind of, I think at the time you explained to me, you went back to the textbooks and went, oh, Yeah. Can you talk a little bit about, and you talked a little bit about that today at this field day at Tom Cotter's farm, some of the soil health dogma that maybe held farmers back a little bit, and maybe now we're seeing that this is helping some farmers like Tom Cotter maybe make some advancements on their farm as far as building soil health.
We look at the soil and soil science and agriculture, and we think that we've got it all figured out, and we think that we know everything that's going on. And the more that we learn and the more that we work with farmers and ranchers and see things that are happening in the real world and how we're integrating these complex systems back together, we sort of decoupled agriculture, we decoupled livestock production from row crop production, but that also led to us decoupling the whole idea of all of these cycles that exist in the process. So when we did that, it was, I think part of that came along with the science of being very reductionist in science, where we're looking at some basic science aspects and thinking of things from a very basic point of view without recognizing what's happening in the complex world of all of these interrelated and integrated cycles. And so when it is that we can, take a larger perspective and think of things from a much more open environment as opposed to a closed environment, doing some basic research, we now start to see some of these things that we thought were the dogma or the truth of soil science may not be entirely true, or it may be true again from a certain perspective or a certain level of understanding. So we've limited a lot of the things in the innovations that farmers have done just because a lot of the ways in which we presented information as scientists has told them that they were limited in what they could do, that you can't increase organic matter, that you can't build soil health, that you have to return the same amount of nutrients that you remove from the field back to the field, that you have to do these things. And when we started putting, as scientists, the research and the data and the information in a box, and instead of looking at it in the real natural world, we were sort of came up, I think, against, and it was a little bit of an antagonistic relationship between scientists and farmers and ranchers, because they were seeing things that were happening as they were putting in a lot of these innovative practices and growing things like cover crops in areas where we wouldn't even really recommend growing crops every year, much less putting cover crops in. As they started doing these things and being very successful with it, it changed the way that we had to approach science. And so now it isn't entirely from that reductionist basic science approach, but we now have to look applied and change our context from thinking about how things really may be started. So when we talk about, how growing topsoil takes so long, but that's, if you're really looking at breaking down rock mineral and being able to create soil that way, that can take a long time. But that doesn't mean that that's the only path. And I guess that's what I'm trying to really say is science we've had to learn when we've not just accepted dogma as fact. We're learning that there are a lot of different things that are happening in the real world where it isn't saying that, there are multiple facts that are true. I'm not trying to totally say that, but on many levels, that's the case, is it really isn't just one factual path that we have to follow, but there are many, many aspects in this level of complexity.
I don't want to put words in your mouth, but it seems like I remember in that example in Burleigh County, there was such situations like Gabe Brown would say, I'm seeing this, I'm seeing organic matter levels go up, or I'm seeing my infiltration rates getting better, that kind of thing. And he just kept bugging people like you to come out and actually see it. And it was almost like the farmers were leading the scientists a little bit about kind of what was going on, and it led to a new area of investigation.
Yeah, I would say that is very, very true. I think oftentimes one of the failings in science and in research and for researchers is we get a little bit too caught in what we're doing, because especially as you're going through graduate school and you're at the beginning of your career as a scientist, what you're doing, what you're studying is perfect and it's the only thing that matters. And we're so focused in on that. I remember, when I first went to North Dakota and I had fallen in love with mycorrhizal fungi when I was 19 years old. I tell people,
as everyone does.
as everyone does, everyone should. If they have to wait till 19, they waited too long to fall in love with mycorrhizal fungi. But the minute that you hear about them, you fall in love with them, I should say. And so I fell in love with mycorrhizal fungi, and Dogma with mycorrhizal fungi had always sort of taught us that, if you add too much phosphorus fertilizer, that's going to reduce the amount of mycorrhizal fungi that you have. If you do too much tillage, you're going to have a negative impact on the fungi. If you grow non-mycorrhizal crops in the rotation, that's going to have an impact on the fungi. And it's true, all of those things do have impacts, but it's not a binary choice and it's not black and white in either having an impact or having no impact. There's a wide spectrum in there that, again, I think in the way that we approach research so often, because when we're doing research, things have to have a level of significance, and once you achieve that level of significance, then it's true no matter what, and that's just the way that things are. And that isn't the case. One, there's a lot of things that happen that don't reach the level of statistical significance that we have to recognize are occurring. And the other thing is sometimes things are statistically significant and then the next year they're not. Those very same things are not statistically significant. One, working with mycorrhizal fungi, which are very complex, and just as an example of that statistical significance, I was doing experiments and I had the hardest time because we would run an experiment and we would do this in a growth room. It would be very controlled conditions, and somehow, I have no idea, I've never been able to figure out how, but somehow the plants and the fungus seemed to sense what season of the year it was. We're in a closed room. We were in a basement in a laboratory building, but somehow there was something, and we would try and cold shock the seeds to sort of treat them in a certain way. But there's just something, again, I don't know what it is, but something that they knew that this was the way that things were supposed to be happening. And so, we would try and run experiments, and instead of we'd use these growth rooms so that an experiment, we wouldn't have to take 3 years to get 3 years worth of data. We would just have the seasons run continuously, and that way you could get 3 years worth of data in production. Trying to do that in like a year or a year and a half, it just wouldn't act the same way. And especially the fungus wouldn't act the same way. And so, I don't know what it is, that still have no idea, but I think it helped me to see those things because it helped me to start thinking that there's a lot more going on than we can really see or know. And so when I first went to North Dakota and I had all of these rules in my head that had gotten pounded into my head through graduate school of this is what you need to do for mycorrhizal fungi. And then I was working with farmers that were growing non-mycorrhizal crops like canola, and farmers that were growing other crops in more diverse rotation, and looking at different types of management scenarios and the amount of phosphorus they were adding. And I would really just go back and go through textbooks and go through research papers, and finding that you would have these studies that would show that these anomalies were happening, that it wasn't just those rules that I was taught at the university of this is the way that things are, and you can't see anything outside of that. We would have, there's something with brassicas, which are normally non-mycorrhizal. You could have some brassica roots that sometimes you would find fungal hyphae in it, mycorrhizal hyphae in those roots. We don't think that they're active in those roots, but they were in the roots anyway. And we would also find that having a brassica in the rotation could help to enhance the productivity of some of the other plants in the next growing season, or if you're growing them in a cover crop mixture, they would all work together in these complex synergies. So something is going on beyond just that. And those are the things where one of the big things that I really try and encourage everyone that I know to do is really ask the questions of why. Because when you ask why, that really starts you to, one, figure out what's really at the heart of the issue, but also to try and explore and understand more about why things are happening.
I think that's a really good point. One of the examples you used was no-till, because sometimes the dogma becomes that you can never do tillage, never disturb that soil. But you said, well, actually, if you're asking the right questions, maybe there are times when you need to do some short-term damage to that soil to reset the system a little bit.
Yeah, I think, again, we have put ourselves in boxes. So, research scientists put ourselves in boxes when our conversations with farmers and ranchers. And now within the regenerative agriculture movement, we've come up with principles to regenerative agriculture. We refer to those principles like they are actual fact boxes of what you have to do. What I am learning is that instead of looking at the principles like individual practices that are that binary choice of do it or don't do it, and depending on what it is, if you do the wrong thing, you're wrong or you're bad, and that's the last thing that anyone wants to hear, much less it's the last correct thing to be stating, is if you do it, you're bad, or if you don't do this, you're bad. It is really one of those things where the system is a system. When you create boxes, whether you're putting the principles in a box or labeling in a box or a standard or whatever it is, the minute that you put boxes around things, you really are not, one, fostering innovation, and you're not understanding that there is so much more to the system than just those individual components. So, for no-till, it can be really important. The system naturally has types of soil disturbance that occur that can help to reset the system or to reinvigorate the system, to stimulate the activity of other organisms in the system, microscopic and macroscopic. We've always had that. You have wind and water that have always had an impact on our landscape. You have earth movement, whether you're in an area that does have earthquakes. There's a certain amount of geological movement that is occurring on a continuous basis that is disrupting the soil environment. You had animals, large herds of animals in the U.S. prairies that would cross over and do a soil disturbance. We've had these things that have changed, and what we found is farmers and ranchers who are doing no-till or no soil disturbance for decades are running into some additional issues. And it's really because we haven't allowed that to reset. We learned this lesson in forestry. If you talk to a lot of foresters, you'll see that they learned this lesson. I mean, that was one of the things why they started changing the way that they were doing controlled burns. Because it used to be that, you wouldn't let a forest burn. Well, they realized that you had to have controlled burns. There are certain types of pine trees that the seeds don't sprout, they don't break through the seed coating if there isn't a fire. They have to get exposed to a certain level of temperature. The things that are happening within the ecosystem because of this level of disturbance. But what we've said to ourselves is, oh, all of this is bad. Disturbance is bad. It's destructive. Anything that we see as destructive isn't always destructive. It is looking at how we can. So when I look at the principles, I think of them more as reducing or managing or working with these different types of practices rather than saying no and yes and putting people in these binary choices.
That approach, which you talked about in your presentation, dovetailed really nicely with the field tour that Tom gave us then, because you were talking about, I'm not going to talk about practices. I'm going to talk about the systems approach. We're not going to look at what's the latest equipment or what's the best use of this or that. And then Tom took us out. He showed us, he has this very big picture view of how he looks like at the history of a field. I'm going to graze it 1 year. I'm going to put in summer annuals. I'm going to put in an annual row crop. And it's a very systems approach. I just was really struck at how that kind of blended in with what you were talking about. Is we sometimes get too fixated on this is the practice I have to use on this field this year, instead of maybe observing and then taking that systems big picture kind of approach.
Yeah, I think that big picture approach that can also be very dynamic and responsive because we can't control things. I mean, Tom was talking about this particular field was supposed to go into sweet corn and there was rain and he couldn't plant the corn, and you have these things where you have to be dynamic and flexible. So he's like, then I used it for grazing. And so being able to design a system that is integrated with all of the different, I think of them as trophic levels, and Tom thinks of them as different types of economic income sources. So, what you're able to use to be able to get other income from. And so in being able to do that, and the other thing that I think is really important that Tom has embraced is not just doing that within his individual fields, but within a field, he'll have that level of diversity that he's doing. So, what he's done with his sunflowers, where he's got strips of sunflowers and then strip of a mixture of plants, cover crop mixture, but I would think of it as just sort of a mixture of plants that you'd have growing that he's then using grazing, and he's grazing in between these strips of sunflowers. And that's in one single field. And that's, I think, the other thing that we've kind of gotten wrong in some of the scientific approach to agriculture, but also with the way that we've designed our agricultural landscape, where it's let's just get this field bigger and bigger and bigger. So you took a 100-acre field and you made it a 1,000-acre field, and you're just going to treat that whole field the same. And that you shouldn't be treating that whole field the same, because there was a reason why it was 100 acres to begin with. Right. And so what is it that we could do? And that's one of the things too, when I'm talking with farmers and ranchers, that I will say to them is the systems approach. You need to think about managing every square foot of your farmscape. That includes your front lawn, your tree rows. Every part of your farmscape is about the whole entire system of how the farm is functioning. You can help to manage hydrology, which is an important thing on our farmscape. A lot of times the way we'll deal with water issues is we'll either put in tile drainage, or we'll dig a dugout, or we'll do something like that. Well, that's not managing hydrology across the farmscape. That's not looking at how all of these can be integrated. Just today when we went out on the tour, and Tom's farm is along the migratory path for the monarch butterflies, and we saw all of the butterflies that were in the trees that were in his yard. How can we look at managing not just for monarch butterflies, but also for predatory insects and other pollinators and those types of things? It isn't just putting in a pollinator strip in your field, but can you manage your ditches and your dugouts and your tree rows, all of those things as part of your farmscape to optimize the efficiencies of your whole farm system?
Yeah, that was like a Hollywood moment. We were pulling out for the field tour, and he stopped. Hundreds of monarchs swarming. And he said, and it was Tom, he knows how to communicate well. He said it was a teachable moment. He said, I'm always looking for signs. I'm always monitoring. Am I on the right path? And he said, this is an example. I'm on the right path. Chris, I was wondering if you could talk about one of the things that seems very important to you, and I think was a really good angle, because I would say the majority of farmers who are here today are very familiar with the soil health principles that people have talked about for years. Depending on who you talk to, there's either 5 or 6, but the basis of it is this whole idea of you're looking at keeping your land protected, integrating livestock, just minimizing disturbance as much as possible, that kind of thing. But I thought you brought a really interesting angle into it, in that you kind of have a carbon-centric view of the soil health principles. And I think that's a really important piece, because sometimes people, when you have these principles that are always laid out there on a PowerPoint, you're like, oh, okay. But you don't really think deeply about what does that mean. But I liked, and I guess maybe carbon is your context a little bit, but can you talk about that kind of carbon-centric approach to the soil health principles?
For me, that has become, and probably because of my love of mycorrhizal fungi and the linkage between the above ground and the below ground that mycorrhizal fungi are involved in that whole carbon economy where the plants have to basically pay for the nutrients they get from the mycorrhizal fungi and the benefits they get from the mycorrhizal fungi by giving them carbon. That sort of helped frame for me the principles for soil health. So for me, it's less about, again, the individual practices or the binary choices of do this or do that, but more about how that's going to impact carbon flow. Because I think the reason that I get excited about talking about it that way is the outcome that we're really looking for and why we're looking at regenerative agriculture and what we're doing is that outcome is really regenerating the soil. We can all agree that what we're really trying to do is to get more organic matter, to get more soil. And so if the practices or the principles are seen from a practice standpoint, but we're not connecting the practices to carbon and we're not connecting the principles to carbon and how we're impacting carbon, how are we going to actually achieve that outcome that we want to achieve? I've worked with a few different projects where we're sort of trying to use best management practices or beneficial management practices, BMPs, which are, again, practices. It's a practice-based approach. But the outcome that they want to see is, again, healthier soil. Well, if your focus is not starting and following that whole entire process through soil health, but rather focusing on mechanics and chemicals and those types of things, you can miss the forest for the trees. Yeah. And that's really what I'm trying to look at and help to work with farmers and ranchers in trying to do. And to me, then, the practices that could be utilized to achieve those principles, again, the principles are to regenerate soil, to get more organic matter. That's what the principles are focused in on. Then you start looking at maybe some individual practices that you could use to achieve those various principles, but it opens up those practices where you almost have limitless options and opportunities. You know, if we start, again, going back to tillage, if you start saying, well, the principle is no-till. Well, if the principle is no-till, what do you mean by no-till? There's at least 50 versions of no-till, and whose version are we talking about here? Because it's not all of the same. What are you doing if we're just focusing on the practices? It becomes very difficult to figure out how to define that. Again, from a research standpoint, it becomes almost impossible unless I want to impose upon the farmer or rancher to do very controlled experiments, which puts me back in that reductionist approach, and I'm not seeing how the system is working. So I had to sort of redevelop the way in which I was looking at the science in order to be able to figure out how to design experiments and how to be asking questions and working with farmers and ranchers to understand what was happening. And, you know, it was kind of like a light bulb moment where I had to thump myself on my head and just say, it's about carbon, stupid. Yeah. Is kind of, the whole, it's economy, stupid. It's about carbon, stupid, is really where we are at. It's about carbon, stupid. And if that's the thing that becomes the foundation that we look at, I think it also is fundamentally life-giving. And because carbon is life, we're carbon-based organisms, we all work for food, all of those things become that. And now as a farmer or rancher, and Tom today and everyone was excited about going out. And, you know, people, we were talking at the end about people who come out and want to take pictures out with his sunflowers because they can look at those sunflowers and it emotes within people that idea of life-giving and the sun and something that is beautiful and green and sunny and all of the things that are about life. So I think the principles need to be life-giving as opposed to being a stick that are pounding people and causing antagonistic relationships between people. You know, there's a lot of people within the regenerative ag movement who say if you don't have cattle, you're not regenerative. And that isn't the case, and that can't be the case. We can't set up something in which we're pushing farmers against each other. When you think about livestock, it's what is the idea of having an animal damage a plant that is something that is driving carbon. And that's what the integration of livestock is about, is the animal grazing, but you're basically damaging a plant. What is that is enhancing carbon flows? And we know that it does, and we can see, how it affects rooting depths and how it affects carbon going deeper into the soil and all of those things that we will see by doing that. But again, you're damaging the plant. And so, I talked some about this whole idea of another way of looking at this is treating the soil like we're supposed to treat ourselves to be healthy. That we want to have gold medal winning Olympic athletic soils. And so, in doing that, it is having a certain amount of stressors, having challenges, doing a little bit of damage. That's how athletes get to be good performers, is they basically damage and break muscle fibers, and your body has to put in work to regrow and rebuild those muscles. And all of those things that are happening are a way of cycling and utilizing carbon. So, what they eat and how they eat and when they eat all dictates how they're going to utilize that carbon to actually build a healthier body. The same thing is true for the soil. We need to look at, again, grazing. What is it that grazing is doing from a carbon perspective? Mm-hmm. And so when I started asking myself that question of why does grazing work? Again, going back to that why, instead of saying, well, you just need to have a grazer. Well, why? What is it that the grazer is doing that is causing those issues that you're seeing? The same thing is true for tillage. What is tillage doing that is causing the loss of carbon? And can we still have soil disturbance? Because we know we do, that has maybe some loss of soil carbon, but also could help to potentially get an influx of carbon going below ground. And again, reinvigorating and resetting the system that can be important. And when you start looking at it that way, it ends up, again, changing the way you look at the principles from a soil perspective, mm-hmm. as opposed to a practice, what we as humans are doing.
One of the things that you tied into nicely was this idea of, there's the I guess the brass ring, the thing people are always reaching for is trying to make that soil self-sufficient. And the system we have set up right now is we're really outsourcing the microbial activity, what could be done by microbial, those little workers down in there in the soil. We're kind of outsourcing that, and when you do that, it's a little bit like outsourcing people. Your community all of a sudden is empty, and it can't be self-sufficient. I mean, I think that's a really important concept to think about, this idea of what could that soil be doing that we're kind of not allowing it to do, I guess.
That's another one of those principles that I look at as far as, the inputs that we're bringing into the system. It's reducing synthetic and off-farm inputs. And the whole idea is not that we need to completely eliminate those things, but we need to think about when we're using them and why we're using them and what that is going to be providing with us. And again, like with what happens with outsourcing, if a company is going to make investments rather than outsourcing, they're going to make an investment into the community and into the factory or whatever it is, rather than outsourcing those jobs. What that can do as far as all of those multi-layer effects that can happen, where again, you don't have to say that everything has to get pulled out all at once, but you're actually maybe retooling what it is that you were making at the factory so that you don't have to outsource. All of these ways in which the system is going to be functioning to maintain that community and that diversity that's going to allow for that functionality. And you really, when it comes to the microbial community, getting that functionality going when the plants first start growing. Mm-hmm. So, at the beginning of the growing season or early in the spring, having those be a part of addressing the issues that seedling is having is really going to help to get that community activity occurring and building that soil health and building those carbon flows through the whole entire system.
Not to pick on no-till. No-till is a wonderful practice, but it just is an example of getting fixated on a practice. One of the analogies you used was doing no-till without building soil biology by, say, integrating cover crops and diversity, that type of thing, is a little bit like putting a tourniquet on a bleeding patient to stop the bleeding, someone who's injured, without feeding them a little bit.
Yeah, it really, I think it's a very good analogy to use because when we do tillage, yes, the soil is going to bleed carbon. And if our idea is to put more carbon below ground and to regenerate soils and build carbon, we don't want bleeding to happen. But again, bleeding is going to happen whether we do it or not. It's a part of the natural cycle. And so we can put tourniquets on, we can help to manage the bleeding, keeping it under control so that it doesn't cause major issues. But if we don't get the patient fluids, if we don't give them food, if we don't allow for the resources that are needed, the carbon that's needed for blood cells to be produced again, the patient's going to die anyway. And that's a lot of what's happened to our soils is when we focus on these individual practices, we're seeing farmers and ranchers who are basically saying, well, I checked all of the boxes. I'm doing all of the right things. I'm doing what the box told me to do, but it's not performing in the way that I think that it should. And again, because we're not attaching it to the outcome that we want to have of regenerating soil and building carbon, we're just attaching it to individual practices. You miss the forest for the trees. I don't want to keep saying that over and over again, but I think that that's really what's happening. And so then you get a lot of farmers and ranchers who are just like, yeah, this regenerative ag thing doesn't work. I got to quit doing this. And, I've talked to a lot of farmers who've done no-till for 2 to 3 to 4 decades who are now like, you know what, I think I got to get the plow out. Well, maybe you wouldn't have been in this situation if we would have known and worked together, everyone in thinking about tillage a little bit differently, so that it wouldn't have gotten to this point where you probably do need to get the plow out. What is it that we could do to help to manage these things in a different way? And if you do have to get the plow out, you have to get the plow out. I'm not going to kick you out of the club, and that's, again, I think that's where we build a lot of antagonistic relationships that are really detrimental to us getting to the point where my goal, and I doubt it's going to happen in my lifetime, but my goal is not that we would have a regenerative label or an organic label or any label like that, but we would have food, and anything that is food that is grown in such a way that we've had to add a lot of inputs, instead of talking about labeling what we don't do, we should label what we do. I don't want to have a regenerative ag label because I don't want to have this adversarial relationship among farmers because I did all the right things and I got this label and you're bad because you didn't do nobody wins in that game. Yeah. Nobody wins in that game. Agriculture, farmers and ranchers do the most important job on the planet. Agriculture is the most important thing that we could possibly be doing. We need to really fundamentally work on how we can help to support and design a system and the infrastructure to support that system that is going to keep that going for millennia.
In the next episode of Ear to the Ground, Chris Nichols talks about how regenerative farming can beat the Amazon Prime delivery system in its own game, and addresses whether we really can create a completely self-sufficient soil biome. Chris also describes what she finds terrifying about our current food and farm system. For more on building soil health profitably, see the podcast page for Ear to the Ground episode 387 at landstewardshipproject.org. On that page, you'll also find a podcast interview I did with Tom Cotter, as well as one I did with Chris Nichols way back in 2012. We've also provided a link to the original series of articles I did on the Burleigh County Soil Health Team. If you have comments or suggestions about this podcast, contact Brian DeVore at bdevore@landstewardshipproject.org, or you can call 612-816-9342. By the way, it helps us greatly if you can give Ear to the Ground a rating on whatever podcast platform you utilize. And word of mouth is the best way to spread the news about our podcast. If you like what you hear, tell at least one person about LSP's Ear to the Ground. Thanks to Laura Borgendale, a Western Minnesota musician, for Ear to the Ground's theme music. And a special thank you to all of Land Stewardship Project's members who make initiatives such as this podcast possible. If you're not a member, visit landstewardshipproject.org to learn how you can support LSP. Thanks for listening.